Hey everyone, I am Priyanshi Agrawal and welcome back to my YouTube channel. Today we will be solving today's Leetcode daily challenge, which is redundant connection. So let's see what is this question and how we can solve it. So in this problem, a tree is an undirected graph that is connected and has no cycles. Okay, and you are given a graph that started as a tree with n nodes labeled from 1 to n with one additional edge added. Okay, the added edge has two different vertices chosen from 1 to n and was not an edge that already existed. And the graph is represented as an array edges of length n where edges I is equals to ai comma bi indicates that there is an edge between nodes ai and bi in the graph. And we need to return an edge that can be removed so that the resulting graph is a tree of n nodes. And if there are multiple answers, return the answer that occurs last in the input. Okay, so in this question, you have been given with an array of edges which represents that there is an edge between 1 and 2, 1 and 3, and then 2 and 3. Okay, and we need to return the redundant edge which can be removed so that it has no cycles, so that this can become a tree of n nodes and n edges, n minus 1 edges. Right now it has n edges because of which it contains a cycle. So we need to return the edge which can be removed. Okay, so as you can see from this example, we can remove either this edge, right? Again, this is a connected component, connected tree. And after removing the edge, the tree should be connected. Okay, so in this example, if we remove this edge, then this would be fine. Okay, and what if we remove another edge? This one, yeah, this will also work. What if we remove this edge? Yeah, this will also work. But we have been given that if we have multiple answers, then we need to return the answer that occurs last in the input. So in the here 2 comma 3 is the last in the input. So we will remove 2 comma 3 and our output will be 2 comma 3. Okay. Now let's see another example too. Okay, so in this example, which edges we can remove? Okay, so let's see, can we remove this edge? Let's see, if we will remove this edge, then don't you think this will become a disconnected graph? So we can't remove this edge. This edge can't be removed. Okay, and you can see we can't remove this edge. Then 1, 2, 3, and 4 are cyclic. So we can remove any of the one edges from them, and we need to remove the edge which occurs last in the input. So which occurs last in the input among these four edges? 1 comma 4 occurs last in the input, so our output will be 1 comma 4. Okay, so here are two observations that we need to remove the edge in the way that it should not contain any cycle and it should be connected graph. Okay, okay. And there's one more observation, like observation or topic. If you have heard about very known topic, which is MST, or I would say minimum spanning tree. I think if you have heard about it, if no, then also no worries, I will tell you. So what is a minimum spanning tree? Minimum spanning tree is also a graph which contains some edges, but it contains the edges, it contains the minimum number of edges which can create a graph. Okay, like this is a minimum spanning tree, but like if we connect this graph, then it contains a cycle, but there is one redundant edge among of them. So minimum spanning tree is a graph which can be created with the minimum number of edges. And there are two algorithms of creating a minimum spanning tree, that is Prim's and Kruskal's, right? But here, like in Prim's algorithm, we use, if you know, like we use the priority queue, and in the Kruskal's algorithm, we can use the disjoint set algorithm. But as you can see, like for the minimum spanning tree, edges are weighted, but These edges are not weighted. These are unweighted, undirected edges. So there is no point of thinking regarding minimum spanning tree. But like we can think of disjoint set algorithm. Why? Let me tell you. Like, what is a disjoint set algorithm? If you have heard about it, then very well. If you haven't, then I will tell you what is a disjoint set algorithm. So, in this joint set algorithm, we mainly have two functions, union and find. So, what these two functions do? So, find will tell whether two nodes belong to a single component of a graph or not, and union will connect those two nodes if they don't belong to the same component of a graph. Simple. So this in disjoint set union do, but if you want to learn about it in detail, then go to the YouTube and check out some video to learn about disjoint set in detail. That would be very needed for this question too. But this is the basic idea, like what does this joint set do? Like if we have two functions, find and union. Find will tell you whether two nodes belong to a same component or not, and union will connect those two nodes. But if you want to know about the working of the find and union function in detail, then you can surely go to the check out some video on YouTube. Okay, so now the question is that how we can apply this DSU on in this question. So let's say we have two these nodes, right? So let's say we will take two nodes, one and two. We will check whether they belongs to the same component of a graph. No. So we can connect them. Now we will check for 2 and 3. Whether they belongs to the same component? No, these are different. So we will connect them. Now we will check for 3 and 4. Whether they belongs to the same component of the graph? No. So we will also connect them. Now we will check for 1 and 4. Whether they belongs to the same component of the graph? Yeah, they belongs to the same component of the graph. It means we don't need to connect this edge. It means our answer is 4 and we will simply return it. Right? And then if you want to check further as well, then you can check too, like if 1 and 5 belongs to the same component. No. So we can connect it. But we have got our answer here only that we don't need this edge. So we will return it. Simple. So DSU is the easiest algorithm for solving this question. You can also solve this question by DFS. I will tell you the approach only because the DFS code may be little bit difficult as compared to DSU one. So DSU is the most efficient algorithm for solving this question. Okay, so let me tell you the DFS approach also once. So you can decide whatever you want to go with, but I would suggest you go with the DSU one. Okay, so in the DFS, what we do is we will start traversing with a node. Let's say we will start with 5. Then we will go to its child node, right? And then we will go to the child node of 1, right? And then we will go to the child node of 2. And then we will go to the child node of 3. And then we will go to the child node of 4. But what you can see here is that 1 was already visited earlier. And now we are visiting 1 again with 4. So it means you have got your answer, that is 4 comma 1. Right? See here. You can see that 3 was 4 has two sides, 3 and 4. But the 3 was also its parent. So it's fine if parent is visited, but it's not fine if the child node is already visited. So we have got our answer. But you can think that it seems to be very easy right now. But like if let's suppose if you have this node also in this in the question. Right now we don't have because we have been given that we only have n edges. But let's suppose if you had this edge too, then it would be very complex. Like if you go to this also, then you need to remove this one or this one. So this would have become complicated in the case when you have to remove multiple edges. So I am saying that I am trying to say that which approach is best for this kind of question. So DSU is best approach for this kind of questions. So and the complexity of this DFS approach will also be we go of n only because we are doing one iteration to visit all the nodes. Okay, so let's see the DSU code once. So this is a very standard disjoint set class. I hope you know about it. We give its overview. So we first create a constructor, and then there are two functions. One is find ultimate parent, and the second is union. What does ultimate parent do? It will find the ultimate parent of a node. And what does union by rank do? Union by rank will find the parent for both the nodes, and then we decide if the parent is same. It means if the parent is same, it means that let's suppose we have two nodes and its ultimate parent is this, right? And we are calling the union by rank on these two nodes, A and B. So their ultimate parents are same. It means they belong to a same component, right? It means they belong to a same component and we will return false. Okay, so let's see in this question. So in this function, we what if they don't belong to a same component, then we will join those two nodes, right? Okay, so in this question, what we will do, we will start iterating on all the edges and we check if those two nodes belongs to a same component. If they does not belongs, if they belongs to a same component, then this function will return false, right? So that's why I have taken the negation of that DSC by union by rank, because if they belongs to the same component, then our function will return false, and if they belongs to the same component, then only we need to return those that edge in our answer, because that edge is redundant. We can create a graph without that edge as well. Okay, so I hope you get the disjoint set code. Now let's talk about its time and space complexities too. So its time complexity will be big of n, as we are iterating on all the edges. And the time complexity of disjoint set is alpha, that according to a large mathematical computations, don't need to go through them. And that alpha is nearly 1 only, so we can say big of n. And the time complexity of space will also be big of n in the disjoint set. So time and space complexities both are big of n. So this was all for this question. I hope you get it. If you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys. See you in the next video.